All right, what's up, my mathletes? That's right, Miss Muscarella and the Broad Run High School Math Department. We're amazing. We're coming at you with part 2 of our video on special angle pair relationships. So, with that said, let's go. Now here, as we take a look at these pieces in our notes, I want you to notice that these angles, so let me kind of draw a little bit of line in between so we can kind of separate them a little bit. They are going to be what are called non-adjacent. And non-adjacent just means not next to. So even though they're supplementary, and remember that word supplementary, and it's a pair, which means there's only 2 of them. So that means I can have 2 angles that add up to 180 degrees. However, the ones here in these examples, and I'll label it kind of like A, example B, and example C over here. All 3 of those examples, you can see their sum of the 2 individual angles, they do add up to 180. However, they're non-adjacent because they're not next to each other. Now, similarly to that, we can have angles that are next to each other. They share a common vertex and a common side. So let's take a look at these 3 examples here. And again, I'll label one A, one B, and one C. So when we look at that, they do share a common vertex, all right? So the vertex in example A, that's the same for both of them, is this little guy right here, that point C. And in example B, you can see that vertex is right there. In example C, even though it's not drawn in there, you can see where these 2 boxes are kind of hanging out there together at the bottom. If we were to draw a dot there, it would just be right there. That'd be the common vertex. Now, similarly, they also share a common side. All right, they share a common side. So if I look at example A, right here, this ray from C to A, that ray is the same in both angles, the 60-degree angle as well as the 120-degree angle. Likewise, where the 110-degree angle is and the 70-degree angle, both of those share that common side. And these 2 90-degree angles over here, they both share this ray that goes vertically up and down. So when you look at supplementary angles, they can either be next to each other, and they would be called adjacent, or they could be not next to each other, and they would be called non-adjacent. So when we look at that, let's go ahead and define this down here. So a linear pair, so remember, linear means line, pair means 2. Now 2 angles are a linear pair if they are supplementary. So let's write that word in our blank here, supplementary and adjacent. So 2 angles are a linear pair if they are both supplementary and adjacent. Because linear, remember, linear pair, that is going to make a line. And the general equation, kind of like the same one before, you're going to see this come up over and over and over again for a lot of things. We're just going to have angle 1 plus angle 2, whatever those 2 angles are, they're going to have a sum of 180 degrees, just like supplementary angles. Only these are a linear pair. So if they're in a line, they're going to be in a pair. So when you think about that, let's draw a little picture to represent the situation. So we've got a line, right? And on that line, we are going to have 2 rays. And one ray, so they're going to have that common vertex. Remember the common vertex? It doesn't really matter where you extend one ray out from. However, wherever that ray is, that linear pair of angles, they're going to form a line, and that total rotation, so if I were to go from here all the way to there, that is going to be 180 degrees, a straight line. All right, so that is something we always want to be kind of aware of. Now, very often, we'll have to find one of these missing angles. So let's take a look here at example A. We know angle AOC is 136 degrees. So this rotation right here, that part is 136 degrees. And I know if I find this other missing piece right here, ooh, that's kind of gross. Let's go with maybe a little different color. Yeah, that angle right there. So this side right here, that angle has got to be whatever 180 minus 136 gives us. So we'll do that calculation, right? Because we want to make sure our arithmetic's good. So 180 minus 136, when we do that, we get a sum of, or a difference, of 44. So this angle right here would have to be 44 degrees. So we would write down 44 degrees there for the measure of angle B. Now, similarly, if I go to example B, I'm told that the measure of angle WOV is 34. So I'm told how much this angle is right in here. And what we need to do is figure out, all the rest of it. So this side over here, how much is that part? Because I know, remember together, this whole piece, that semicircle right there, more on that later, but a semicircle is going to be 180 degrees. And so, if I take 180 degrees, and I subtract that 34 degrees, that difference will be 146 degrees. So that measure of angle UOW is going to be 146 degrees. All right, so hopefully you're doing okay with that. Now these next two, I think you can do those on your own. So go ahead and hit pause, calculate that angle that you're trying to find, and then come on back, check it out, and let's see how you did. All right, so how did we do with that, mathletes? Hopefully, you came up with the measure of angle ROS to be 123. Cool, 1, 2, 3, 3 consecutive numbers. And for part D, you came up with 100 degrees, which is crazy hot at any time of the year. So those are the two values for that. And remember, every single one of these, when you're taking a look at this angle on the line is going to be 180 degrees. So if you know one of those angles, then you can find the other one by simply subtracting. So let's go ahead and use that information and take a look at example 3 here. And that'll be the last piece of this video here, part 2. So again, I want to kind of take a look at some things here. So from angle 1 to angle 2, like those two angles right there, they do form a semicircle or a straight line, because I've got this piece right here, angle 1, and right next to it, this other piece right here, angle 2. So those two parts together do make a semicircle. So one pair would be angle 1 and angle 2. So that is one linear pair. Because remember, linear, they're going to make a line. Pair, they're two. So angle 1 and angle 2 is one linear pair. Now, similarly, I've got this other pair down here at the bottom. Numbers, angles 3 and 4. So angle 3 and angle 4, they would be another linear pair. Now, I think you could probably do this one on your own. So if you're cool with this, go ahead and hit pause, come back, check it out, see how you did. For everybody else, let's go on. Right, so when we take a look at example, this one over in the upper right-hand corner, check this out, right? We've got angles 4 and 5. They are going to make a linear pair. So that's one linear pair right there. And my other linear pair is going to be angles 3 and 6. So again, we're making a line. Two angles that are next to each other make a straight line. So angle 3 and angle 6. So that's going to be another linear pair. So we've got two pairs for each one of these pieces so far. And when we look at the other one, so down here at example with angles 5, 6, 7, 8, you can kind of see this. Maybe you're getting better at kind of recognizing this. So angle 5 and angle 8, that is one pair. And the other pair would be, boom, angles 6 and 7. So those are another set of linear pairs for those ones. And then take a look at this guy with angles 2, 3, 4, 5. You know, sometimes you might feel like you're playing Yahtzee with some of these. So we got 2, 3, 4, 5. That'd be a small straight in Yahtzee, right? But check it out. 3 and 4, boom. Two right angles, they share the common vertex, yeah? And they are next to each other. So angles 3 and 4, they would be a linear pair. And in this case, they would each be 90. And then the other linear pair, so if I take a look at angles 2 and 5, they're next to each other and they do share a common vertex. And remember, they also share a common side. Ooh, that's kind of big right there. But that common ray right there between the two of them. So next to each other, share a common ray, common endpoint. So that would also be another linear pair. So angle 2 and angle 5. And it doesn't matter if you put the 5 first and the 2 second. Don't get yourself hung up on that. So that will be that. Now, for this one, get you prepped on this one, you may want to make several different drawings because we've got 4 problems to do here. So make 3 other copies of example 4 next to that, right? More on that in the next video. We'll come back, we'll play with this one, and after that, we'll see you soon. Thanks so much for watching, and I'll catch you later. Peace.